So, last time we were going over rational expressions. So let's start off a little bit of a refresher and something that should be easy for us. X squared minus 7x plus 10 all over x squared minus 4. So the idea here is that we need to simplify this as well as state any excluded values. Remember that excluded values are things that we cannot plug in for x, because then it would make the bottom of this expression 0. And of course we cannot have 0 on the bottom of a fraction, because that means we're dividing by 0, which in algebra is not possible. Okay, so what we need to do is factor the top and the bottom. If we factor it and we see that there are common factors on the top and the bottom, then we can cancel them out to get a simplified version. So let's go ahead and do that. We'll start with the top here. We have x squared minus 7x plus 10. So this is a quadratic. What should we do to factor it? What method do we use? Any ideas? Okay, there's 3 terms, so we can't use difference of squares. Also, if we look at these terms, they don't have anything in common, so we can't use GCF factoring. So there's one more thing that we can use. AC method, yes. So our A is positive 1, our C is positive 10, so our AC is positive 10, because 1 times 10 is 10. So now we need factors of 10, that would be 1 and 10, 2 and 5. And we need a pair of these that will combine to give us negative 7 here. So what pair will give us 7 if we combine them? Yeah, if we make this negative 2 and this negative 5, negative 2 times negative 5 gives us positive 10. That works. Negative 2 plus negative 5 gives us negative 7. So that works. So we will use these to replace negative 7x. Of course, that would then become negative 2x and negative 5x. So we can now use our box method, but do we need to? No. Why not? What tells us that we can use our shortcut here? Not that. Yes. The number in front of x squared is positive 1. Remember, what do we call this number in front of our x squared here? It is the leading what? Leading coefficient. So our leading coefficient is positive 1. That means that we don't need to go through the box method. Of course you could. You'd still get the same answer. But seeing that we have a positive 1 here for our leading coefficient means that we can just take these and use them to create our factors. So our 2 factors here would be x minus 2 and x minus 5. So there's the top part factored. Now we want to factor the bottom part. Now this one is not a trinomial like this one, so we can't use the AC method on it. We've got to go for something else. Well, do they have something in common? Do they have a GCF? Well, this one's x and this one's 4, and I don't see anything in common between those two. So no GCF there. Is it a difference of squares? Yes. So x squared is a square of x. 4 is a square of 2. So because this is a difference of squares, we know that it will come out to have 2 factors. One of them being positive in the middle, one of them being negative in the middle. So what are the numbers that we fill into here? So this one would be what plus what? X plus 2. And this one? X minus 2. Of course, that is from taking the square root of both of these. The square root of x squared is x. The square root of 4 is 2. So now that we have these factored, we can look for common factors between the top and bottom. And if we see any, we can go ahead and cancel them. So, do we see any common factors? X minus 2. We can cancel those out, and so the simplified version is x minus 5 over x plus 2. But of course, this is not all of our answer. We need something else here. We need the excluded values. We need to know what we cannot plug in for x. So for that, we look to the bottom. And we say that if either of these factors were to come out to 0, if we plug something in for x, then the whole thing would become 0, and we don't want that. So we need to take x plus 2, this one right here, and x minus 2, this one right here, and say, well, neither of these can ever come out to be 0. And then solve. So, solving this one, we would need to subtract 2 from both sides. That gives us that x cannot be equal to negative 2. Same thing here. We add 2 to both sides. So that gives us x cannot be equal to positive 2. So x cannot be equal to plus or minus 2. Any questions? Nope, makes sense. All right. So let's start picking up where we left off on Monday. Okay. So if we can simplify these, just normal single fraction thing, we can also simplify more complex versions. So let's say we have z to the third, I'm sorry, not z to the third, z to the second, plus 12z plus 36 all over 3z squared plus 25z plus 42 times 3z squared minus 5z minus 28. Oh, and over z plus 6. Okay. So first of all, we have a bunch of trinomials. We know we can factor those. Can we factor z plus 6? Or is it already as simple as it will go? Yeah, it's already as simple as it will go. So we don't need to worry about it. All right. So let's go ahead and factor the other ones and see if we can find some common factors, starting with this one. So we got to use AC method, and what is my A? 1. Leading coefficient, positive 1. And my C is 36. So 1 times 36 is 36. And we want a pair of factors of 36 that will add to get 12. Any ideas? Yeah. In fact, this one is what we call a perfect square trinomial. where we have 6 times 6 to get 36, and then add those two to get 12. So a perfect square right there. Okay, and the leading coefficient is 1, so we don't need to go through our box method. So we have factors z plus 6 and z plus 6. Perfect square. Okay? Now let's try this one on the bottom. Again, what's my leading coefficient? What's my A for this one on the bottom? And my C? Okay, so 3 times 42, 126, good. So now we need to find factors of 126. Well, there's a good many of them. So 1 and 126, of course, 2 and 63, 3 and 42. There we go, 21 and 6. If we multiply 21 and 6, it'll give us that 42, and it will also combine to give us 25. Now, can we use our shortcut here, or do we have to use the box method? Yeah, we got to use that box method because our leading coefficient is not positive 1. Okay, so we'll go ahead and draw up our box. So first term, 3z squared, goes in the first box. Last term, 42, goes in the last box. And then, like we said, 6 and 21 are the numbers we're using to replace 25. So I'll go ahead and put 6z here. It's positive, so positive there. And then 21z here. And again, it's positive. So let's go ahead and factor this thing. First row, 3z squared and 6z. What do they both have in common? Something we can divide them both by. 3 and z, good. Second row, 21, yeah, they actually have an entire 21 in common. Okay, first column, good. And second column, not 6. You have 6z and 40, oh, I'm sorry, I thought that was a z. Yes, 6. Okay, so put those in here. We have 3z plus 6. And we have 3z plus 21. All right. Next one. Again, leading coefficient is not positive 1, so we're going to have to go all the way through this one. Our AC is 3 times negative 28, which gives us what? Okay, negative 84. So, factors of 84. 1 and 84, 2 and 42, 3 and 28, 4 and 21, 6 and 14, 7 and 12. I believe that's all of them. Yeah, 7 and 12 is what we're going to be using here because we can combine them to get negative 5. Now, which one needs to be negative and which one needs to be positive? Negative 12, yeah. So, draw up our box. First term, first box, 3z squared. Last term, last box, negative 28. Then, we can put negative 12z here and positive 7z here. Now let's find the factors they have in common. So, first row, what do they have in common? 3z. Second row. 7. First column. Z. Second column. Yeah, 4. Okay? So, this one we have Z minus 4. And this one is 3Z plus 7. All right. And then, of course, like we said, this one can't factor, so it's just going to drop down. So, do we have anything common between top and bottom? What do we have? Z plus 6, yeah. Okay. Anything else? Yeah, I don't really see anything else. So let's go ahead and combine everything together. So we have Z plus 6, Z minus 4, 3Z plus 7, three Z plus 6, and 3Z plus 21. And just for time's sake, let's see, this would be Z cannot equal 2. I'm sorry, that'd be negative 2. Z cannot equal negative 7, and Z cannot equal negative 6. Any questions? None? All right. So let's add another layer to this. And I would say that if you can do this next problem, you can do anything in this course. 2y squared plus 8y minus 24 all over y squared minus 5y plus 6 divided by 3y squared plus 26y plus 48 all over 12y squared minus 4y minus 96. And this is why I allow y'all to use calculators on your quiz. Okay, let's take care of something just real quick here before we start factoring anything. I have a fraction divided by a fraction. What should I do? Flip? Flip that one? Is anything else going to happen? Yes, this will change into multiply. So we're going to keep, change, flip. Good. So 2y squared plus 8y minus 24 over y squared minus 5y plus 6, now times 12y squared minus 4y minus 96 all over 3y squared plus 26y plus 48. Oof. Okay, now we can start factoring things. Let's just start with this one. Our a is 2, our c is negative 24, so what's our AC? Negative 48, okay. So we want a factor pair of negative 48 that's going to give us positive 8 there in the middle. What can we use? 12 and what? Negative 4. Okay. So 12 times negative 4 does indeed give us positive 48. However, if we do 12 minus 4, or positive 12 plus negative 4, we get positive 8 in the middle. Good. So real quick, we will just do our box method. Okay, 2y squared, negative 24, then let's put negative 4y here and positive 12y there. Okay, first row, what can come out? 2y. Second row. Good. First column. Second column. Good. So we've got one of our quadratics factored now. So we have 2y minus 4 times 2y plus 12. Good. All right. Let's go ahead and factor this one. So a is 1, c is 6, ac is 6. And we need to combine these factors to get negative 5. What can we use? Problem there would be that if we multiply negative 6 and positive 1, we get a negative 6. We want a positive 6. Negative 3 and negative 2, good. So negative 3 and negative 2 will combine to give us negative 5, but multiply to give us positive 6. And our leading coefficient is positive 1, so we don't even need to use the box method on this one. We can just say that it is y plus 2, I'm sorry, not plus, y minus 2, and y minus 3. Okay, any questions so far? All right, go to the other side. Whew. A is 12, C is negative 96. Let's see, 12 times 96 is enormous. However, is there something else we can do before we multiply A times C here? Yes, good. 12, 4, and 96 all have 4 in common. In other words, we can factor a GCF out of this. So let's go ahead and factor that GCF out. Okay, so we can take that 4 out. Now what we'll be left with is, let's see, 3y squared minus y minus 24. Okay, so now instead of having 12 and 96 as our A and C, giving us a huge number, we have 3 and 24 for our A and C. So let's see, 3 times 24 is, whoops, yeah, there we go. So 72, factors of 72. And we need to get pair of factors that will give us -1 in the middle there. -8 and 9, good. So -8, +9, is that what you said? Remember, we need a -1 in the middle. Yeah, opposite. So -9, +8. Okay, so find some space for a box method here. So let's see what we get. We have 3y squared and -24. We'll do -9y here and +8y there. So what can we take out of this first row? 3y. Second row. Good. First column. Good. Second column. 3. All right, so our two factors are y minus 3 and 3y plus 8. Oh, getting close. So we now on the bottom have 3y squared plus 26y plus 48. Okay. So can we do a GCF on this one, since we were able to do it on the other one? Let's see. This is 26. Can 26 divided by 3? No. So, yeah, that's not going to work for us. Unfortunately, 48 will divide by 3. It's just that 26 that's given us a problem here. Okay, so let's see. 48 times 3 for our AC is 144. So we need factors of 144 that will give us 26. Well, 12 times 12 is in there, but that'll give us 24 when we add them. So what else might give us 144? Okay, let's see. 12 has a lot of 2's and 3's in it. Or I should say 144 has a lot of 2's and 3's in it. Okay, so what are some numbers we can make with 2's and 3's? 4, that's not going to quite work. That's going to give us 36, I think. We can do 6, not going to quite work either. How about 8? So 144 divided by 8 is 18. So let's see, 18 plus 8 equals 26. So there we go. So this one, we can make our box. And let's see, first one is 3y squared. Last one is 48. Then here we can put positive 18y and positive, what do we say, 8y? Okay. So, first row, what can we take out? 3y. Second row, what can we take out? 8, good. First column, y. Second column, okay. So let's see here. We have y plus 6 and 3y plus 8. So do we see any common factors? Where do we have common factors? 3y plus 8 for sure. You can cross those out. Anywhere else? Y minus 3, cross those out. And I'm not seeing any others. Okay. So altogether, this would be 2y minus 4 times 2y plus 12. Okay, and then y minus 2 and y plus 6. Okay, I'm going to give us a hint right now, this is not correct. Well, besides the fact that I missed the 4 that's supposed to be here. Can anyone see somewhere else that we can factor? Yes. So if we look back up here, 2y, 8y, and 24, they can all be divided by 2, can't they? That's why you should always start by trying a GCF. See if these can all be divided by something. See if you can simplify it. So let's try this one more time. If we divide it by 2, that'll give us 2 times y squared plus 4y minus 12. Okay. So factors of 12 that will combine to give positive 4. What could we do? 6 and negative 2. Okay. So then that would mean that these new factors are 2 times, let's see, y plus 6 and y minus 2. So now let's try canceling some more things. Do we see anywhere else that we can cancel? Yes. Y minus 2 can cancel. Y plus 6 can cancel. Okay, so let's ignore this wrong answer we got. Shoot, man. Looks like most everything canceled. What are we left with? Good. 2 and 4, which is 8. So, a lot of work. Big one. But like I said, if you can do this one, you can probably do any question posed to you in this class. And again, like I said, always, anytime you're looking at anything that you're trying to factor, try a GCF first. It does not matter if it's a binomial, a trinomial, whatever. Always try to get a GCF out first if you can. Any questions? None? All right. Let's do something slightly different. So we've seen multiplying and dividing these rational expressions. Let's try adding and subtracting them. So here I've got 3 over y minus 2 minus 4 over y plus 1 equals 1. Okay. So let's think back way to the beginning of our course this semester. we've actually seen something kind of similar to this. We said that if we have an equation with fractions in it, well, fractions are kind of annoying to work with, aren't they? However, again, in an equation with fractions, if we can get everything over the same denominator, then we can cancel those denominators and just have what's left on top. In other words, no fractions. So let's try to do that here. As well, I mean, if we're going to not do that and try to work with the fractions themselves, we still need common denominators to be able to subtract them or add them. So we're going to need common denominators anyway. Okay, so to start us off, let's go ahead and make this a fraction as well. And now we need common denominators. Well, how do we make a common denominator between y minus 2 and y plus 1? Exactly. Remember that if all else fails, and if you have something like 1/3 plus 1/2, well, the easiest way to get a common denominator between these two is to just multiply the denominators. So let's go ahead and do that. Y minus 2, we're going to go ahead and multiply by y plus 1. Am I going to sit here and physically multiply it? Not yet. And I'll tell you why in a few minutes, but let's just get this laid out for ourselves. Well, if we multiply the bottom by that, we have to multiply the top by that as well, so 3 times y plus 1. Okay, then subtract. We have y plus 1, so we need to multiply it by y minus 2. Okay, and again, whatever we multiply the bottom by, we need to multiply the top by that as well. So now we have 4 times y minus 2. And we want to get a common denominator on this one as well. Well, it's pretty easy, it's 1. So we have y minus 2 times y plus 1. Same thing to the top. Y minus 2 times y plus 1. Are there any questions at this point? Has what I've done make sense? Make sense so far? All right. So again, we just got in common denominator. I'll be fine, don't worry. Common denominators. And like I said, if we get everything over the same denominator, that means we can go ahead and cancel those denominators. So all these are gone. No longer with us. Okay. Well, at this point, we can now say that we just have 3 times y plus 1 minus 4 times y minus 2 equals y minus 2 times y plus 1. No more fractions. And that's why I didn't want to multiply these things. Sure, I could have gone ahead and multiplied them, but I was just going to cancel them, so there wouldn't be any point to it. Now is the time that we should multiply. So let's go ahead and do that. We've got 3 times y plus 1, so what's that going to come out to be? 3y plus 3, good. Minus 4 times y minus 2, what's that going to come out to be? Let's be careful about something real quick. Yeah, this should really be positive because this is a negative 4. So let's go ahead and distribute that in. So now we have negative 4y plus 8. All right, equals, let's see, if we multiply these, y times y is y squared, y times 1 is y, negative 2 times y is negative 2y, and then negative 2 times 1 is negative 2. So let's start combining like terms. We've got 3y minus 4y. How many y do we have? 3 minus 4, negative 1, so negative y. Okay? Then we have 3 and 8, so together they make what? 11? Okay, equals, let's see, over here we've got like terms of y and negative 2y, so 1 minus 2 is what? Yeah, negative y, so y squared minus y minus 2. And now, let's get everything by itself. In fact, instead of trying to get all the numbers on one side and the letters on the other, let's just put everything together on one side. We'll see why in a minute. So let's see, negative y, bring it over here, that'd be plus y. What does that give us? 11 equals y squared, well that cancels, doesn't it? Minus 2. You know what, never mind. Let's actually go ahead and get the numbers to the other side. I'll show it to you that way. So plus 2 to both sides. So now we have 13 equals y squared. Well, how do we get y by itself? How do we get that square off of y? Square root. So take the square root of both sides, and that means that we have y equals square root of 13. But that's not our entire answer. We need something else here to complete this answer. Anybody know? Is what? Not necessary. Think about what we just did. We just took a square root, right? And there we go. Yes, plus or minus. Like I've said before, if we have the square root of 4, yeah, we usually say that's 2. Because 2 times 2 is 4. However, negative 2 times negative 2 is also positive 4. So when we take square roots, at this point we need to be saying plus or minus in all of our answers. So the true answer here is y equals plus or minus the square root of 13. Another involved problem, for sure. But really the big thing here is just knowing how to get those common denominators. Just multiply the denominators together. And hey, you don't even have to actually multiply them together because they're going to cancel. You don't need to worry about them. All we need to worry about is stuff on top. Any questions? None? Okay. Well then. I believe that will do it for today. Remember, there is a quiz on Friday, and it's going to be all this stuff. So know how to factor. I will put one of these on that quiz as well, so be prepared for that. It's going to be a long one. Most of them are going to be things like this, short ones. And there will also be one or two questions about sets, so know how to solve things with inequalities in them, the greater than or equal to, or the less than, that kind of thing. All right, so I hope y'all have a good day, and I'll see you on Friday.